For chapter 10, we're going to first start by interpreting graphs. Please hit pause, try the warm-up, and then we'll go through the answers. Remember, when you're finding the percent, you have to make it a decimal. 0.2 of means times 360. Plug it in your calculator. 0.2 times 360, you should have gotten 72. 75% of 360, 0.75 times 360. And you got 270. And 1/4 of 360, you could do 1/4 times 360. Remember, multiplying by 1/4 is the same thing as dividing by 4, so you should get 90. We're going to talk about a couple of different types of graphs and when it's best to use each different type. Most of this is by discussion. A bar graph would be something that looks like this. Notice the bars are not touching. You would have a title, label your axes, and you would have scales on your X and Y axis. It displays data with vertical or horizontal bars. A bar graph could also be horizontally. Again, with the title, axes labeled. It is used when displaying data into categories. For example, you might use a bar graph when you're talking about whether you're playing different sports, favorite foods, anytime it's any kind of different category. A line graph displays data using line segments. It is used when displaying data over a period of time. So you might say your height over time. You might say how much rain during the day. Another thing might be temperature during the day. A circle graph shows parts of a whole. It is used when showing percent. So circle graphs would look like this. The total circle would be 100%. When you would add up all of the different percents, it would have to add to be 100%. Some examples of a circle graph might be when you're talking about the percents of fruit in a fruit salad. It might be the percent of ingredients in something. Now we're going to take a look at some practice problems. We're not going to be doing any burger videos. I just have some here. So see example 1, which is right here. Use the bar graph for exercises 3 and 4. Estimate the total number of animals at the shelter. So if you notice, this is technically is a scale of 5. 5, 10, 15, 20, 25, 30, 35, 40. Notice it was important labeled. There are 5, 10, 15 dogs, 30, it's not quite to 35, so I'd say 32. You can't have 32 and a half cats because that wouldn't make sense. So either round it to 32 or 33. Rabbits, there are 10 rabbits. And guinea pigs, there are 20 guinea pigs. So for the total animals, you estimate, and you would do 15 plus 32 plus 10 plus 20, you would have 77 animals. There are 3 times as many what as what? So look over your chart. There's 3 times as many something as something. Well, there's 2 times as many guinea pigs as rabbits. I would say there's about, it's not quite, but there's about 3 times as many cats as there are rabbits. Let's look at a double bar graph. So we're comparing 2 different ones. About how much more is a club level seat at Stadium A than B? So Stadium A is in purple. So I'm just looking at the purple. Club level, here they're going by 10 since it's in the middle. I would say this is about 45 and this is about, it's not quite to 30, I'm going to say 28. So I would do 45 minus 28. Plug it in my calculator and get 17, about $17. Which type of seat is the closest in price? So I would look and say, well, which two bars are closer? That's, we know 17, that's a little bit closer. That's a little closer. These two are almost the same. So I would say box seats. And bar graphs are great that you can tell just by looking at the picture. It says, describe one relationship between the ticket prices at Stadium A and Stadium B. So if I'm describing one relationship between the two, let's just look at the bleacher seats. You know what? Let's talk about club level because we already said them. I would say Stadium A's club level tickets are approximately $17 more than Stadium B's. Now we're going to look at a line graph. It says use a line graph for exercises 8 and 9. Estimate the number of tickets sold during the week of the greatest sales. So where would be the greatest sales? So it says estimate the number of tickets sold during the week of the greatest sales. These are your tickets sold. Where are they the greatest? Right here's the greatest. Let's look at our scale. 5, 10, 15, 20, 25, 30. So I'd say about 35 tickets. Which 1 week period saw the greatest change? Well, this is a pretty small change. I'd say that's really only about like 2 or 3. Oh, this one went up about 5. That one went down about 5. Oh, this one went down about 10. So I would say between week 4 and 5. Between week 4 and 5. You have a double line graph. When was the support for the two candidates the closest? You have candidate A and candidate B. I would say they are the closest. So let's look and see on the graph where they are the closest. Right here, they're pretty close. They get further apart. Right here, 1 week before the election, they're right on top of each other, the two dots. So I would say week 1 before the election. The second question says, estimate the difference in voter support for the candidates 5 weeks before the election. So at 5 weeks, candidate A is not quite at 60, so I'm going to say that's 58. Candidate B is right over here at 40. So I'm going to do 58 minus 40 is 18. So I would say the difference is 18. Describe the general trends for voter support during the two candidates. I would have said that for candidate A, it started much higher. At about 6 weeks before the election, they got very close. Then A took the lead again until it started to drop and B started to gain around week 3. And at week 1 before the election, they were right tied. Now we're going to lastly look at a circle graph. About what percent of the total number of cars are hopper cars? Remember, to find percent, it's the part over the whole. So for hopper cars, I have 8 hopper cars. I need to add them all up. 8 plus 16 plus 24 box cars plus 11 gondola cars plus 33 tank cars plus 4 engine cars gives me a total of 96 cars. I'm going to double check my math. 4 plus 33 plus 11 plus 24 plus 16 plus 8. Yep, got 96 again. So 8 over 96. Now I need to simplify my fraction. They're both even, so I'm going to divide them both by 2. And I get 4 over 96 divided by 2 is 48. They're both now divisible by 4. And I get 1 over 48 divided by 4 is going to give you 12. So it's 1/12. And then let's make that as a percent. 1 divided by 12. I would say it's 0.083, so it's 8.3% are hopper cars in the freight train. Number 28, about what percent of the total number of cars are gondola or tank? So now I want to add the gondola is 11 plus the tanks are 33, still over 96. When I add those two together, I'm going to get 44 out of 96. These are both going to be divisible by 4. So you're going to get 11 over 96 divided by 4 is 24. 11 divided by 24 is 45.8% are gondola or tank cars.